Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. I think it's been a long time, but I'm back. So I have 20 questions for you. I mean, it's a quiz questions that I want us to go through as we are preparing for our exam. So stay tuned and make sure that you go along with me. Let's jump right in. So the first question is, we want to prove that this is the same as this when we take the I mean we can express this one as the same as this. So now first, let's think about the hyperbolic function of sine. So this is the hyperbolic function. That's the reason why we have the h here. So this is our normal sine function, and then the h, so hyperbolic function of sine. So we know that the hyperbolic function of sine, which is of, let's say, x, or let me use u, is equal to e to the power u minus u divided by 2. So this is the hyperbolic function, right? You can use x here, x here, x here. It's also the same thing, right? Then because I want to form this, now remember that the hyperbolic function of sine of all squared of x over 2 is the same as the hyperbolic function of x over 2 all squared, right? So the idea is that we try to, establish this. So now that we have this, now we want to form this one first. So we can say that u is the same as, x over 2. So now we can replace it by that. So we are going to have x over 2, and this is going to give us x over 2 minus x over 2 divided by 2. So we just replace the u by x over 2, which is here. Now the last thing that we need to do to check if this is true or false is to square this. So we are going to square both sides, and then let's see what we are going to get. So hyperbolic function x over 2 all squared is the same as this, over 2 minus x over 2 all divided by 2 all squared. So we just need to expand this and see if it's the same as this. Okay, so let's do that. I'll just pick this one here. So I'm going to have e to the power x over 2 minus x over 2 divided by 2 times e to the power x over 2 minus e to the power minus x over 2. So because it's true or false, we try to check if something is off, then we just go. So this is divided by 4. And indeed, when you multiply this one by this, we are getting 4. So we don't have any problem with that. So the denominator will be 4. And let's multiply this by this. And, indices, if I have a to the power x times a to the power x, this is the same as a x plus x, which is the same as a to the power 2x, right? So when the base are the same, we add the exponent, right? So the base are the same, so we are just going to add the top here. So let's do that quick. So if I have e to the power x over 2 plus x over 2, this is the same as e to the power 2x over 2, and this is the same as this, right? So when I multiply this to this, I'm going to have e to the power x. Is there anything off? Okay, let's finish it up because I think it's almost getting to true because we are not seeing anything off. Then I can multiply this to this, and since the base are the same and I'm adding the top, x over 2 minus x over 2 is going to be 0. So I'm going to have e to the power 0, which is 1. So it's going to be minus 1 because of this minus here. Then I multiply this one to this, also the same thing. I'm going to have minus 1 because I have the minus here. And then when I add this and this, I'm going to get 0. E to the power 0 is 1. Then I multiply this by this. Now this is minus going to give us positive, plus e to the power. Now minus of this plus minus of this is going to give us minus x. Great. So now what will be the simplification here? This is the same as e to the power x plus e to the power minus x minus 2 divided by 4. So let me see if that's right. Yes, this is minus 2. And then we have this one here. So let's check if that's that. E to the power x plus e to the power minus this minus 2 all divided by 4, which is the same as this. So we are going to claim that this is true. Great. This is true. So for us to do this, we should be record that this is true. So if you record that this is true, I think the rest will be very simple for you to go through, right? The rest is simplification. Let's go to question 2. Now question 2 says that if the inverse is of the function f, if this is the inverse of the function f, then this represents the derivative of this. Is this true? Okay, let's think about the inverse function theorem, right? What is the inverse function theorem? Now we can write the inverse function theorem like this. So minus f inverse all to the power prime, because we are talking about the derivative here, is actually equal to 1 divided by f prime of f inverse of x, right? So for us to say that this is representing the derivative of this, we need to have the reciprocal of this. If we have 1 over this, then indeed it's going to be the derivative of f prime. But since we don't have the reciprocal, then we are going to say that this is false, right? So this is indeed false. So if you know that this is equal to this, then you will know that this is going to be false indeed, right? So that's basically the idea here. Now let's move to question 3 first. Okay, question 3. We want to take the derivative of this function right here. All right, now let's record the exponential function. Okay, right. So y is equal to e to the power, let me use u here. Now we said for us to differentiate the exponential function, and we are going to have something like the y over the x, which is equal to, now we take the derivative of what is on the top, which is going to give us u prime, then we multiply it by the whole function again. So if we record this, then we can make use of this. So now when you compare this to this, we can see that our u is equal to x to the power n, right? And when you look at the formula here, we need u prime. So what will be u prime? Okay, let's do that. U prime, using the power rule, we are going to have n x n minus 1, right? So now using our formula here, we just do substitution for u prime and u, and then we have gotten the results that we need here. So this is going to be dy over the x, which is equal to, what is u prime? Okay, n x n minus 1, and then e to the power, what is u? U is x to the power n. So this is what you are going to get. So I just did substitution for this. U is here, and then u prime is also here. So let's get to the options, and we can see that I think this should be D, right? This is going to give us D. Very beautiful. Now let's go to question 4. So you see that everything is very simple here, right? Let's get to question 4. Now question 4, we want to find the derivative of this. Now record. So this is very important if you remember the formulas, right? So when I differentiate secant inverse of, let's say, u, this is the same as, let me bring this one down here. This is the same as 1 divided by absolute value of u, square root of u squared minus 1 times u prime. So if we're able to record this, then this becomes very easy, right? So this becomes very easy. Now this is the sum rule. I mean, we are adding it. So we can take derivative of this separately and derivative of this separately, then we add. But we know that when we differentiate this is going to give us 5. So all of them are having plus 5, which is true. So the only thing that we need to do here, we need to check for this one. So now when I compare this to this here, I can see that my u is 4x. Okay, great. So let's do that. U is 4x. So u is equal to 4x. This implies that u prime is equal to 4. So all we just need to do is we just need to replace u and u prime by 4x and then 4. Then we are done. So let's do that. D over dx secant inverse of 4x now will be equal to 1 divided by, so u is 4x, so absolute of 4x, square root of 4x squared minus 1 times u prime is 4. Let's try and simplify it, right? Absolute of, a constant 4 is still 4. So this is going to be 4. This is going to be, so since we are multiplying this by this, 4 times 1 will be 4. So this is going to be 4 divided by 4 absolute of x square root of, now 4 squared is 16 and x squared is x squared minus 1. Now we can take care of the 4 and we are going to have 1 divided by absolute of x, 16x squared minus 1. So let's go through the options. And now remember, this is what is giving us this, right? So we need to add the plus 5. When you differentiate 5x, this is what we are going to get, which is the plus 5 here. So we have all the plus 5. And then this is 1 divided. So we also have all 1 divided by, we have the absolute of x also there. Now we need to look for 16x squared minus 1, which is right here. Great. So this should be giving us b. Yes. So this one should be giving us the b here. So it's very simple with derivative, right? It's very simple with derivative. Now let's do this one too. Oh, I enjoyed this one too. Now let's look at this one. Now recall. It's very important to recall, right? So recall that if I have f of x, which is equal to a, which is constant, to the power u, now then f prime of x is equal to, this is maintain the function. So we maintain the whole function, right? We take the derivative of what is on the top. So now we differentiate what is on the top. Then we take natural log of the base. That's very beautiful, right? So maintain the function, differentiate what is on the top, and take ln of the base. So everything is taken care of. We maintain everything here. We went to the top, and then we came to the down. So the top is taking the derivative. The down, the base is taking the ln of that. So now let's compare this one to this. Now we can see that if I want to compare this, I can see that a is equal to 10 and u is equal to 1 over x, right? Like when I compare this to this. So a is 10 and then u is that. But we need u prime. So let's go through the process. Now this is the same as x to the power minus 1. So u prime will be equal to minus 1, right? Bring the minus 1 out and down and then have this. So we are using the power rule. So minus x minus 2. And this can be written as minus 1 divided by x squared. Beautiful. So let's do substitution, then we are done. F prime of x is going to be, so what is a to the power u? So okay, a is here and u is also here. So we are going to have 10 to the power 1 over x, then times u prime. Okay, so times minus 1 over x squared, which is here, right? Then times ln of the base, which is 10. So ln of the base is 10. So I think they rearrange this one to have this. The ln of 10 came first before having this one here. So you can see that I think is C, right? And we have this one here, we have this one here, and we have this one here. Yeah, so if you record this, I think you are good to go. Very simple, right? Yeah, we have 15 more to go. So stay tuned and stay here. Now, here we want to find the domain of this function, right? Now, remember that anytime you have a square root standing alone without being under the denominator of a function, then we are saying that anything under this one should be greater than or equal to 0. So that's one thing that you need to remember with the radicals. Now, anytime we have natural log of x2, the x value should be also greater than 0. So here we have two conditions that we need to play along with here. So here, the natural log of x should be greater than 0. And then here, if I have square root of x should be greater than or equal to 0. So that's the idea that we are going to use to do this. All right, so let's see what we can do here. So I can pick 1 minus natural log of x being greater than or equal to 0. Now remember, this x is not under the root, right? So I'm going to have this. Why? Because the radical tells me that if I have this, it should be greater than or equal to 0, right? Because we don't want to have negative values under the radical. Okay, good. Now we also know that ln of x, because when we plug in 0, ln of 0 is negative infinity. We don't want to deal with 0. So basically, we need to exclude 0. So here, when I solve this one here, I'm going to have 1 greater than or equal to x. So I move this one to this side, and then I become positive. And this one can be written as x natural log of x less than or equal to 1, right? So now remember here, now we can see that we want to find the domain. We want to look at the x value, where we can take the x values. Now remember, we are saying that from here, x should be greater than 0 already, right? I mean, x should be greater than 0. And remember, as x is increasing, this will be bounded by 1 because of the length function here, right? So we know that when x is 0, we have excluded that. But when x is 1, this is going to be 0, which is true. And as s is increasing, this is going to hit 1 here. So it means that our x should be lying between 0 and 1, which is the same as this. So the best option here is to choose B. Beautiful. I hope you are enjoying it. Okay, let's look at question 7. So question 7, we want to find the derivative. All we need to do is recall. So let's do recall here with question 7. Okay, so recall that when I differentiate sine inverse of x, this is equal to 1 divided by square root of 1 minus x squared. When I take the derivative of this with respect to cos inverse of x, this is minus square root of 1 minus x squared. And now because this one is just x, this one is like a composite function. So what I'm going to do here is I'm going to make use of the u, right? So that we can have the composite function. So this with respect to x, tan inverse, or the arctan of u is 1 divided by 1 plus u squared times u prime. So this is not a composite function. That's why I used it. Now remember, we are taking the derivative. So when I take the derivative of this, I'll have this, plus when I take the derivative of this, I'm going to have this. But remember, this and this are inverse, right? This is positive and this is negative. So the derivative of this plus the derivative of this is equal to 0. So when I add this to this, I'm going to get 0. So the only concern is on this. Now, when I compare this to this, I can see that my u is the square root of x. So now that's what we are concerned about. So let's see that. Now u is equal to the square root of x, and this is the same as x to the power 1 over 2. So we need u prime. U prime is going to be 1 over 2 x to the power, subtract 1.5 minus 1 over 2, right? So that's what we are going to get. Now this can be written as 1 over 2 square root of, or let's say x to the power 1 over 2, and this is the same as 1 divided by 2 square root of x. So now we know u prime, so let's do substitution with that. So d over dx of tan inverse of square root of x is the same as, so we are using the formula here. We are going to have 1 divided by 1 plus u squared. This is u, so this is going to be x squared times 1 divided by this, because we need to multiply by u prime, and u prime is equal to this. Now let's do some small simplification here, and then we are done, right? Now when I multiply this by this, I'm going to have 1. Now this will cancel this, so it's going to be just 1 plus what? X, right? That's basically what you are going to get from there. So I'll have 2 here, multiplying the whole of this. I'm going to have 2 times. Now when I cancel this and this, I'm going to have 1 plus x. So I'm going to have 1 plus x. And then I have my square root also here. So I can have my square root of x here. Or probably for you to understand it well, This is the same as 2x and then x plus 1, right? So I have this 2 square root of x here. Then I multiply it by, when I cancel this one, I'm going to have 1 plus x. So 1 plus 1 plus x multiplying this is going to give us this. So we know that this is 0, this is 0. So the answer from this option should be just this one. And let me just lift this one up so that we can compare with the solution that we have there. Okay, and yes, it's this one here, because I can write this one as 1 divided by 2, 1 plus x, and then square root of x. Okay, let me write this one well. Yeah. So this one, the one should come before the x, which is the same thing. So that's what we are going to get. So that one should be the b, right? So this and this cancel out, and then it will be left with only this. Let's look at 8. Okay, 8. Record the quotient rule. So let's use the quotient rule here, right? So what is the quotient rule? Okay, fine. Quotient rule. If I have, let's say, y, which is equal to u divided by v, then dy over dx is equal to v u prime minus u v prime divided by v squared. So when I compare this to this, I know that my u is equal to ln of x, s, and my v is equal to s. Now remember, this function is in terms of s, so we are going to differentiate with respect to s, right? So u prime is going to be 1 divided by s, because we know that if we want to differentiate a length function, it's 1 divided by what is inside the parentheses. So differentiating a length function is this. If I'm differentiating a length function with respect to u, this is 1 divided by u times u prime. So when I differentiate this, it's 1 divided by x times s prime, but x prime is 1 because we are differentiating with respect to x. And then v prime will be equal to 1. Cool. Now let's do substitution. So now k prime of x will be equal to, we are using the formula here. So v is s times u prime is 1 over x minus u is natural log of s times v prime is 1 divided by v squared, which is x squared here. So we can cancel this and this and have 1 minus this divided by x squared. I think it's separated, so we can write this one as 1 over x squared minus x squared. Okay, so no option, right? No option here. No option here. Okay. All right, let's look at 9. Okay, this is very beautiful, right? So now look at this function that is given here. E to the power this. Now let's break it down. Now remember that if I have exponential function and then the natural log function of u, this is basically equal to u, right? I mean, this and this are inverse of each other. So if this and this comes together, it's equal to what is here. So this function that we have here is actually equal to sine of x squared. Very simple. So we break this down, and then so what they wanted us to do is just y is equal to this. So they wanted us to know if we know this property right here. So now dy over dx will not be difficult. So I find dy over dx. Now we need to use the chain rule here. So first, the derivative is going to hit the sign. So when I differentiate sine, I'm going to have cos x squared times, then I need to differentiate what is inside, which is going to give me 2x. So the idea is that this is a composite function. So if you recall, y is equal to sine of u, and we differentiate this with respect to x, dy over the x is equal to cos of u times u prime. So if I are doing it this way, then you can see that here our u is equal to x squared, so u prime is equal to 2x. So if I'm using this formula here, I'm going to have cos of u, which is x squared, which is here, times u prime, which is 2x, which is also here. Very simple. So now this is going to give us 2x cos of x squared. And this is a beautiful A right here. Let's look at question 10, and we have 10 more to go. Right. All right. So we want to differentiate this, right? We have a function x to the power x, y to the power y is equal to 1. Now let's make our life easy here. Okay. How can we make our life easy here? We can take len of these functions so that we can make our life easy. So let's do that. I'll take a len of this equal to len of that. Now I know that len of 1 is equal to 0, right? And I also know that if I have len of AB, this is the same as len of A plus len of B, right? The natural log. So it means that I can write this one as natural log of x squared plus natural log of, oops, this one should be x, and then natural log of y to the power y, which is equal to 0 because this is 0. Now we also know that if I have log of, let's say, x to the power, or let me say u to the power a, this is the same as a u, right? So I can write this one to as x plus y. So we've made our life easy. I mean, at least we've gone a long way to come here. So now we can take the derivative, right? Now life is easy here. So let us enjoy life. Okay, so now we can use the product rule here because the function is going to multiply. So we use the product rule. Now, how do you use the product rule here? Okay, fine. Product rule is if I have y, which is equal to AB, then y prime is going to be a b prime plus b a prime, right? So let me compare this to this. So I can assume that my a is equal to x and my b is equal to the natural log of x. So I need a prime and I need b prime. What is a prime? When I differentiate x with respect to x, I'm going to have 1. And when I differentiate the natural log of x, we know that we should be getting 1 over x from the idea that, where's the len function? Did I differentiate len function somewhere here? I think I wiped it up. Yeah, so it's fine. So this is going to give us this. So now let's put them in here, like this times this and this times that. So when I take the derivative of x natural log of x, this is going to be, so a times b prime, a times b prime. So I'm going to have x times 1 over x plus b times a prime, so this times that. So I'm going to have natural log of x times 1. And we can take this one off, and we are going to have 1 plus natural log of x. So let's put this one down. Let's go to the y. Now, if we are doing the same thing for y, we can say that a is y, and then b is equal to natural log of y. Now, don't forget here we are differentiating the function with respect to x. So when I differentiate a, I'm going to have y prime, because it's going to be dy over dx. This one, the reason why we are getting 1 is when I differentiate with respect to x, I'm going to have dx over dx. dx cancel dx and get 1. But this one is going to be dy over dx, which is the same as y prime. Then let's look at b prime. Okay, b prime is going to be, so natural log, we know that it's kind of like, if I want to differentiate natural log of this is going to be 1 divided by u times u prime, right? So here our u is y, so this is going to be 1 divided by y times u prime is still y prime. So this is what we're going to get. Beautiful. So let's try and then find out d over dx of y natural log of y. So multiply a to b prime, so this times that, we are going to have y times y prime over y plus b times a prime is going to be natural log of y times y prime. Let's simplify that. We can take care of this, guys, and then we have plus y prime natural log of y. Okay, so this is beautiful. So let's put them together, right? We are taking the derivative of this plus the derivative of this is equal to this. So now we know that this is equal to this plus this. So we are going to add this, and it should be equal to 0 because we are taking the derivative from there. Right. So let me open another small sheet here, and then let's continue from there. Okay, let me bring the option again. So we are still on question 10, and that's what we've got into now. So now we are going to have 1 plus natural log of x plus y prime plus y prime natural log of y is equal to 0. Now we are finding for the y over the x, which is y prime. So here I can move this to the right, and then I can factor y prime out. So I'm going to have y prime out 1 plus natural log of y, which is equal to, when I move this one, I'm going to have minus 1 minus natural log of this. So I need y prime, so I can divide it by this. And here I can decide to factor minus 1 out. So minus 1 out, 1 plus natural log of x divided by 1 plus natural log of y. So this is what we need, and none of them is here. Yeah, none of them is here, so no option. No option. Now we can also have another strategy here that we can use to do, right? I mean, we can differentiate straight away without applying the length. So let me just go through that one quick for those that they want, straightforward. They don't want to go this. So I can use the product rule here, the same thing, AB, and I can assign A to x to the power x and B to x to the m, y to the power y. Now let's differentiate. What is A prime? Now don't forget, this function here is like x to the power base x. So this is going to be a lot of complication here. So I think I will not go through that, because if I want to do this, I need to write this one as e to the power ln of x to the power x, which is the same as x ln of x. And I think it's basically going to give us the same thing like the way we are doing it. So you see that this was the same as what we had here. Where is it? Here, right? It's just we are taking the e. So I think let's stick to this one. So no option. Now let's move to question 11. Let's move to question 11. Now we want to differentiate this, right? So we have the exponential function, and we record the exponential function, right? E to the power u. So if y is equal to this, then y prime is u prime e to the power u. So that's the exponential function. So now we can see that when you compare, u is equal to the hyperbolic function of cos, which is this. So we need u prime. And remember, when you take the derivative of the hyperbolic function, you get the hyperbolic function of sine without negative. So you need to pay attention. We know that when you differentiate the actual trig function, which is cos, you get minus sine, but here you are going to get positive. So this is going to give us the hyperbolic function of sine for x times, then we differentiate what is inside, change rule. So this is going to give us 4. So this is the same as 4 hyperbolic function of sine 4x. So now what will be f prime? I mean, this is going to be, we are using the formula here. U prime is this. So 4 hyperbolic function of sine, and then e to the power u, by u is here. And I'm going to have the cos, hyperbolic function of cos 4x. Right. So this should be, I think, a here. Yeah, that's right. So some of them, if you know it, you can just go straight and then just do it. Right. It's beautiful to do mathematics, most especially the differentiation aspect. Right. So the question is asking us to find inverse of x prime. Now we have two ways of doing this, right? They've given us f of x. So one thing that we can do here is we can just take the derivative of this. Let's do that. So I have f inverse of x is equal to square root of x. This is the same as x to the power 1 over 2. So f prime, f inverse of prime is going to be 1 over 2 drops down minus 1 over 2 when I subtract 1. So this is the same as 1 over 2 x to the power 1 over 2, which is the same as 1 over 2 square root of x, which is b. Now, another way we can do this is we can record the formula for f inverse prime using the inverse function theorem. F prime of x, f inverse of x of prime is the same as 1 divided by f prime of f inverse of x. So now, since we have f of x here, we can find f prime. So what is f prime of x? Okay, that's going to be 2x because it's x squared there. Then we need to put this one inside this. So now f prime of f inverse of x will be equal to, so now we are changing the x to this. So we are going to have just 2 f inverse of x. Now what is f inverse of x? Okay, good. That's square root of 2. Square root of x. So this is 2 square root of x. And then we come and put it here. So you see that this is the same as this. It's going to be 1 divided by this, which is right here. So any of them that comes in mind, it's going to be perfect for you to do it. But I think since this one is multiple choice, the best way to do this is just take derivative straight away from this, like the one that we did first, and then you are done without going through the theorem. Because this one, you need to remember, you need to record the formula before you can do that. Okay, let's look at 13, and then we have 7 more to go. I hope you are enjoying it. You can give us thumbs up, comment, for us to see you are enjoying maths with us. All right, so let's continue. F prime. Okay, now f of x, let's make our life easy here, right? Use some small properties to make our life easy here. Now this, remember, if I have ab, I can write this one as the natural log of a plus natural log of b. Oh, my handwriting is becoming messy. Okay. So what can I write? How can I write this one? This is the same as x squared plus natural log of sine x. So this is beautiful. Now, after doing this, now we know that for me to differentiate length function of u, this is 1 divided by u times u prime. So let's use that idea. Now, f prime of x will be equal to 1 divided by, so here when I compare u, here u is x squared. So x squared times u prime. What is u here? U here is x squared, and u here is sine x. So this is going to give me 2x. Beautiful. Plus 1 divided by u, which is sine x. Now u prime here is cos of x. So times cos of x. Which is also nice, right? So let's try and simplify this. One of the x can cancel, so this is 2 over x plus cos of x divided by sine of x. But we know that cos of x over sine of x is the cotangent. So this is plus the cotangent of x. So x, 2 over x, is that right? Oh, this is 4, right? Oh, sorry, this is 4. So let me have the 4 here. Oh, that's so bad. This is 4. So this is also going to be 4, and this is going to be 4x to the power 3. Okay, so this will change to 4. 3 of the x will cancel 3 of this, so this one will be left with this. So this one should be 4. So 4 over x. Okay, so I think the options, all of them is reciprocated, right? This one should be, this is plus this. So if this one was 4 over x, the option should have been A. So here, no option here. Yeah, no option. Okay. Now let's look at 14. Okay. 14, this is a nice way to look at this, right? We want to check which one is not one-to-one. So all the functions should be distinct, right? One-to-one means that A goes to B, C goes to D, like everybody is distinct. So let's see, this is 0, 1, 2, 3. They are all distinct. This is 1, 2, 3, 4. None of them is repeating. Let's come here. This is 0, 1, 2, 3. Okay. This is 0, 1, 2, 3. None of them is repeating. So 0 goes to 0, 1 goes to 1, 2 goes to 2, 3 goes to 3. That's the same for the A. Now we have 0, 1, 2, 3. Now we have 1, we have 0, we have 3, we have 2. None of them is repeating. So 0 goes to 1, 1 goes to 0, 2 goes to 3, and 3 goes to 4. So it's also 1 to 1. Now let's look at the last one. We have 0, 1, 2, 3. They are all distinct. We have 1, we have 0, we have 0. Okay, so 0, 0 is repeating. 0, 0 is repeating here. So if I do this, I'm going to have 0, 1, 2, 3. And then in the codomain, so this will be the domain. In the codomain, because I have 1, 0, 0, 2, 0, 0 is repeating itself, so I can repeat it 1 and have 1, 2. So 0 goes to 1, 1 goes to 0, 2 also goes to 0, and 3 goes to 2. So this is not 1 to 1 because 2 and 3 is mapping to 0. 1 and 2 is mapping to 0. So the best option here should be this. This one should be C. And the best option here is going to be D here. 6 more to go. Now, which of the following tests is used to determine whether a function, whether a given expression is 1 to 1? Okay. So for 1 to 1, now we need to record that we have two of them. We have the horizontal line test and we have the vertical line test, which is always, they are all here. Now, the record that the vertical line test, we use this to test if it is a function, right? So this goes with function. This goes with function. So we use a vertical line test to check if a given graph or if a given function, or let me say if a given graph is a function. Yes. And we use the horizontal line to check if the function is what, 1 to 1. So I think this is the best option for us to choose. This is going to be A here. Yeah. Now the derivative of this. Okay, so we want to take the derivative of this, and we need to use this hyperbolic function, right? This is the hyperbolic function. Okay, so let me write this one well, and then we'll see what we can do. The hyperbolic function of cos of A over x. Now we need to recall just the hyperbolic function, the formula that we are going to use, and then if we're able to record that, we are good to go. So dy over the x, or let's say the hyperbolic function of u is equal to 1 divided by square root of u squared minus 1 times u prime. So this is the hyperbolic function. Is this true? Yes, this is true, because when it is the sine function, we have 1 minus u squared. Yes, so the hyperbolic function is going to be this, because we know that from the identity, we know that cos plus sine is equal to 1. Right, so when you move this one here, you are going to have 1 minus sine. But the hyperbolic functions is cos minus sine. I think so, is equal to 1. So if you want to make sine a subject, you are going to have cos minus 1 is equal to sine. Yeah, that's true. Yeah, so this one moves here and this one moves here, and then we have the minus. So yeah, I just wanted to know that if this one is true. Okay, so this is true. So when you compare this to this, we see that our u is equal to A over x. We need u prime, and we are differentiating with respect to x. Now this is the same as ax to the power minus 1. So this is u prime is going to be minus a x to the power minus 2, and this is the same as minus a divided by x squared. All right, so let's do substitution and then we are done. Let's do that. This is going to be 1 divided by u is a over x all squared minus 1 times u prime, which is minus a divided by x squared. Okay, so they did a lot of simplification. So let's also do a lot of simplification here. So this, when I multiply the top, I'm going to have minus a divided by, then I'm going to have x squared, square root of, this is going to be x squared divided by x squared minus 1. This is minus a divided by x squared. Now, under the root, we are going to have a squared minus x squared divided by x using the lowest common factor, right? And this is the same as minus a square root of. Now, remember that if I have a squared over b squared, this is the same as square root of a squared over square root of b squared. And this is the same as, let's say, square root of a. This is the same as a over b, right? So this one can be written as x squared, and I'm going to have square root of a squared minus x squared divided by square root of x squared. And square root of x squared is going to give us x. So this is going to give us x. And one of the x here will cancel one of the x here. So I'm going to have minus a divided by x square root of this minus x squared. Yeah. So we have minus a. Okay, so this is out because we need minus a, which is here. And we have x, which is also here. And we have a squared minus x squared. So a squared minus x squared. Okay, so I think probably it should be this one. Yes, a squared minus x squared. So probably it's going to be a. All right, so that will be the 16. 4 more to go. Maybe I'll leave you one for you to do. Right. Let me do this one. I'll give you the 18 to do so that you can leave your answer in the comment section. Okay, let's finish this one. We want to find the inverse. Let's assume that f of x is equal to y. So y is equal to natural log of x plus 1. We can interchange x and y and have y plus 1. I want to make y the subject. So since we have the natural log here, we need to take the exponential function here. So let's do that. E to the power x, e to the power y plus 1. And we know that because of this here, the right side is going to be 1 plus y plus 1 e to the power x. And then y will be equal to e to the power x minus 1. Let's look at the option the way they did it. Okay, fine. So y is f inverse of x, and then this is going to be this minus 1. Is that right? Okay. Did I do things right? Oh, okay. So I think I made a mistake here. There is square root. Yeah, there is square root. Sorry about that. So square root. Yep, square root. Okay, so this one will be square root. So before we get to this place, we need to square both sides. So when I square this, this will be now y plus that, and this is now 2x, which is equal to y plus 1, and then now y will be equal to e to the power 2x minus 1. Okay, so now this is f inverse of x, e to the power 2x minus 1. Okay, so 2x minus 1. Okay, so let's see what is happening here. Looking at the option, this is kind of the option, right? Let me shift this one up. So B is kind of the option here, right? Because we have y, this y here, let's see, I'm just thinking about this. So here, if y is equal to this guy, if y is equal to f inverse, then so from here, then f of y is equal to x. Yes, I think this is true. Yeah, it's true. Yes, if y is equal to f inverse of this, then this is true. So we can replace the x by f of y. So I think, yeah, that's what we are getting there. So this will be f inverse of x is equal to e to the power 2 f of y. This is supposed to be f of x. This is what I'm messing up with my head. Okay, let me see that. Okay, let me do something here and see what is going to happen here. So let me interchange x and y here to get to the same point again. Okay, so that I can have f inverse, then y is equal to f of x. Okay, so I think that was the idea that we were taking from there. So I think, yeah, it's still basically going to be b. Yeah, it's going to be b from there. All right, so that will be b. Okay, I will leave question 18 for you to try, right? So this is the function, and we are saying that when you find the inverse, you are going to get this, true or false. So try this and leave your answer in the comment section. Let's do 19 and 20, and then we are done from here. Find the inverse derivative. So inverse derivative means that, one, you need to find the inverse, and when you are done, you differentiate. We have two ways of doing this, but I'll use just the other way. We can use the inverse function theorem by using the formula, but because this is multiple choice, we don't need to do that. We just need to find the inverse, and we differentiate, then we are done. So let's do that. Let's assume that y is equal to 1 over 2, 7. Swap x and y and have 1 divided by 2y plus 7. Let's do the multiplication. 2x square root of y plus 1 is equal to 1. So I multiply this by this. This is over 1. 1 times this, I have this. Let's square both sides. 2x square root of y plus 1 squared is equal to 1 squared. So this is going to be 4x squared y plus 1 is equal to 1, right? So I can square this, because if I have a plus b all squared, this is the same as a squared b squared. So I can square the 2, 4. I can square x, which is this, and then I can square this, which is going to be this. But a plus b squared is not the same as a squared plus b squared. No. So pay attention with that. Now let's make y the subject. I can divide through by x, 4x squared. So y plus 1 is equal to y divided by 4x squared. Then y will be equal to 1 over 4x squared minus 1. So now that we have gotten this one here, now we can decide to differentiate this with respect to x, right? So I can write this one to as y is equal to 1 over 4 x to the power minus 2 minus 1. So let's find, now don't forget this is the inverse of x. So now we want to differentiate the inverse. So inverse of x prime, this is going to be 0. So now minus 2 drops down, minus 2 divided by 4 x to the power minus 3. So this is going to be minus 1 over 2 times, this is the same as 1 over x to the power 3. So minus 1 over 2x to the power 3. So this is what we are going to get, and right here. So what I did here is we found the inverse, which is here, and we took the derivative. The question is saying that inverse derivative. So inverse, then we take the derivative, or the derivative of the inverse. You find the inverse and you take the derivative. Another way that you can do is you can use the idea of this formula that we have here, the inverse function theory, which is equal to 1 divided by f prime of f prime f inverse of x. So after you found the inverse, which is here, you hold it on and you find f prime here. So you see that it's going to be so complicated. Then you do, you know, in direct substitution. This is multiple choice, so it's best for us to go with this one. Now let's look at the last one, then we are done. Find the domain of f inverse of the given function. Okay, so we want to find the f inverse. Now don't forget that when we talk about domain of f inverse of x, this is equal to the range of f inverse. So without even looking at this, I've seen the answer already, because I'm going to find the domain. Like I'm going to find the range of this graph. And I know that this graph, because of this square root here, the maximum that this graph can go is 3 on the y-axis, right? It's going to be 3. So, or maybe, okay, it depends. So this one is going to concave down. So I think the minimum is going to be 3, because this one is supposed to be given as minimum, right? Something like that. So let's see how we can figure this out, right? Let's see how we can figure this one out. So first, you can try to find the inverse before finding the domain, right? It's good. Or you can also use the idea that you can find the range of this function, right? You can find the range of this function. So I'm going to do all the two so that you'll be comfortable with that. So let's first find the inverse, then we find the domain and see if it's going to be that. But let me find the range first. What is the range of this function? Okay, we know that f of x is equal to square root of x squared plus 9. Already, under the square root, this function is greater than or equal to 0, because we know that x is greater than or equal to 0. It's not going to pick negative values. So this function here will be greater than or equal to 0, right? So that's what's going to happen here. Don't forget, this f of x here is y. So it means that automatically y is greater than or equal to 0. That's one side. Okay. Now let's form something here. Now, do we have upper bound here? Let's find out. Now, if I have, let me say 9 is equal to 9. But if I add, let's say, a constant to this, you will see that what is here will be greater than this, right? I mean, it will be greater than or equal to this, because if I add k here, then what is going to happen here is, if k is 0, I'm using the equal to, we get 9 is equal to 9. But if k is 1, you know, this will be greater than this. So now let's assume that k is equal to x squared, so that we can form this. 9 is less than or equal to x plus x squared. Now let's take square root on both sides. Square root of 9 is less than or equal to square root of 9 plus x squared. And square root of this is going to give us 3, less than or equal to. Now this guy here is the f of x, which is y. Now let's look at what is happening here. We said this is already greater than or equal to 0, but we see that because x, where's x? X is greater than 0 and this is squared. There is no way we are going to have upper bound under this, right? Because any value that you are going to put here will increase the function, right? It's going to increase the function. It's going to make this one goes to infinity. So it means that y is greater than 0, is greater than 3 up to infinity. So this one is like less than infinity here. So this is going to be 3 infinity. So the best option here is this one. But let's go to finding the inverse and see if it's going to be working out. So y is equal to square root of x squared plus 9. So interchange x and y squared plus 9. And then square both sides. X squared is equal to y squared plus 9. We will try to make y the subject. Y squared is equal to x squared minus 9. And then making y the subject is going to give us plus or minus square root of x squared minus 9. But remember that x is positive, so there's no way we are going to get negative. So it means that the negative side will go away and have x squared minus 9. Now let's find the domain of this. Now we want to find the domain of this, right? Let's find the domain of this, because this is the inverse now. Okay, so domain x squared minus 9 should be greater than or equal to 0. So x squared is greater than or equal to 3. Sorry, 9. Take the square root. Square root of this is going to be plus or minus 3, but we said x should be greater than 0, so we are going to ignore the and then have 3. So x is greater than 3. So x is greater than 3 is the same as this. And this one will goes to infinity. It will go to infinity here. So that's basically how it's going to be. Because if x is 3, that's when we are going to get 0. When x is something a lot, this will just be going to infinity. There is nothing that's going to, we don't have maximum value here, right? I mean, we don't have maximum value here. So x will be going to infinity. So that will be the domain that we are going to have here. So yeah, B is right. All right, so this is the end of the video. Don't forget to solve question 18, to leave your answer in the comment section. I wish you all the best in your exams. See you in the next video.